morning everyone. Hope you all safe with a good health. With you Ms. Dina Al-Badri, physics teacher for grade 9. Today we will start a new chapter, chapter 18, magnetism. What would the world be like without magnetism? To answer this question, we have to know what is the magnet, what is the property of the magnet, what is the importance of the magnet and uses of the magnet. Magnets and magnetic fields. Chapter 18, section 1. It will be from page 619 to 625. What is the history of magnetism? Magnets are named after a place called Magnesia, found in present-day Greek. Okay, so the word magnets come from that they found these rocks in a place called Magnesia. Okay, did you see this map? Yeah, this place, Greek, we call this place Magnesia. Okay. The iron-based mineral magnetite we used as lodestone or leading stone almost 3,000 years ago. Okay, so what is the history of the magnetism? Magnets are named after a place called Magnesia, found in present-day Greek. The iron-based mineral magnetite was used as a lodestone or leading stone almost 3,000 years ago. See here, this is lodestone, and around it is a small piece of iron ores, which come to stick to these two. The world's first campus, ancient campus. Did you see the shape? There is a shape of the ancient campus. Magnetism background. So we know that they found in magnetism. What is the characteristics of the magnets? Have north pole and south pole, called dipole. Okay, so any magnet has north pole and south pole. Okay, north pole and south pole, except if there is a shape of round magnet, so there is no pole here. Okay, similar to the rule of charge, like poles. What will happen to the like poles? Attract or repel? Repel. And unlike pole, attract. So the first characteristics of the magnet is that the magnet has two poles, north and south. Similar to the rule of the charge, like pole repel and unlike pole attract. Always the magnets appear in pairs, no matter how small the pieces of the magnet are. Each piece always has two poles. Did you see here how the magnets work? North and south. North and south. So the south will attract to the north, south will attract to the north, and so on. Okay, but the similar pole, it will repel each other. Any magnet has a magnetic field, the region where a magnetic force may be detected. So the magnetic field, it is the area around the magnet which the magnetic force appears. Strongest the magnetic force will be at the two poles and represented by the field line. Iron filings and a magnet. Demonstrate the iron filings and the magnet. What will happen when you sprinkle around a magnet? The iron filling lines up with the magnetic field. Did you see here? Okay, this is line represents the magnetic field, and this shape, it means that the unlike pole attract each other and the like pole repel each other. All of this we call it magnetic field. Did you see this line? This means that the magnetic force appears in this area. Okay, so each magnetic lines repulse each other, and this is the cause of the bending of the magnetic lines. Okay, magnetic lines are made of either magnetic A particles. Did you see here? They are unlike poles, so they attract each other. What makes a magnet a magnet? Magnetic property of the material depend on the motion of an atom's electrons. The electrons orbit or revolve the nucleus of the atom and spin like a top. Did you see here how it's made a magnet? Did you see? Electrons revolve around the nucleus in an orbit, in an orbit. Okay, this a shape of the electron. They revolve around the nucleus. This movement of the electron creates a magnetic field around each individual atom. Electrons are in pairs. Electrons spin in an opposite direction, up and down, and magnetic field cancel each other. Not magnetic. One electron don't have a pair, magnetic field don't cancel out, creating a magnetic material. Okay, so in this part, again, the movement of the electron creates magnetic field around each individual atoms. Electrons are in pairs. Electrons spin in an opposite direction, up and down, and magnetic field cancel each other. So there is no magnetism in this area. When electrons don't have a pair, magnetic fields don't cancel each other, so it will create a magnetic material. Okay. Materials that can become magnetized are called free fair materials that can become magnetized are called ferromagnetic. Okay, the material can become magnetized, we call it ferromagnetic. Like the iron, like the nickel, like the copper, all of this material we can change it to become magnetized. In this material, magnetic fields of the individual atom are grouped together to form magnetic domain. Domains form small magnetized region within the material. What is the meaning of the ferromagnetic material? This material we can change it to be a magnet. If the domain are arranged random in different direction, the material is not a magnet. If the domain are aligned in the same direction, the material is a magnet. Okay, so if this domain are arranged random by this shape, okay, in a different direction, so can each one be a magnet? No, there is no magnet here. But when these domains are arranged in the same direction, that you see, in the same direction, the material is a magnet. Okay, that you see here, domain here are lined in a random in different directions, so there is no magnet. But here the domain are arranged in the same direction, so it will be a magnet. It will be a magnet. Any pieces of iron can become a magnet if placed in a magnetic field. The domain will change orientation because of the magnetic field and algae. Okay, so here there is a magnet, here there is no magnet, so they attract each other because south with north they attract each other, but here there is no attraction. Did you see here? There is unmagnetized iron. This slightly magnetized, but this is strong magnetized iron. Okay, when a magnet is broken in two pieces, each piece is an equally strong magnet. How to making or destroying a magnet. Materials that are magnetic all of the time, the magnetized, are called permanent magnets. But ferromagnets material may become magnets by what? Placing in a magnetic field or stroking several times with a magnet. Both way altering the domain of the material. Okay, magnets are weak by banging, hammering the magnet, or heating the magnet. So if you want to destroy the magnet, I will hammering on it or start to heat it. Okay, domain are no longer aligned, so we will make disruptions in the domain, or disrupted